Okay, welcome to section 4.2. Our objective today is we want to be able to find the probability of compound events using addition rules. All right, so the first thing we need to do is we need to establish a definition. And that definition would be for mutually exclusive events. Two events are considered mutually exclusive if they cannot occur at the same time, which means they don't overlap. So let's talk about this. These scenarios are roll one die. These scenarios are pick one card. All right, so first we have to just decide, are they mutually exclusive or not? All right, so if we roll one die, the probability of getting an odd number and the probability or the event of getting an even number. You can't get a number that's even and odd at the same time, which means they don't overlap, which means yes, they're mutually exclusive. All right. How about getting a 3 and getting an odd? Well, getting an odd is 1, 3, or 5. So 3 and 3 occur in both things, so both categories. So that means there is an overlap, which means they're not mutually exclusive. All right. Getting an odd and getting a number less than 4. So an odd is 1, 3, 5. Number less than 4 is 1, 2, 3. 1 and 3 are the overlap, which means these are not mutually exclusive. Getting a number greater than 4 and getting a number less than 4. Well, greater than 4 is 5 and 6. Less than 4 is 1, 2, 3. There's no overlap between these categories, so that means yes, they're mutually exclusive. All right, so pause, try. This is picking one card. Try these 4 categories, then unpause. Getting a 7 and getting a jack, they don't overlap, which means yes, they're mutually exclusive. How about getting a club and getting a king? Well, there's the king of clubs. That would be counted in both categories, so that means they're not mutually exclusive because they do overlap. Right? Getting a face card and getting an ace. Be careful, face cards are just jack, queens, and kings, the ones with human faces on them. An ace does not have a human on it. So these don't overlap, which means they are mutually exclusive. No overlap means yes, mutually exclusive. Now getting a face card and getting a spade. Well, face card is jack, queen, king, and spades, there's a jack, queen, king of spades. So they do overlap, which means they're not mutually exclusive. All right. Now you might be saying, like, why did we practice this? Why is this definition important? Well, this entire lesson is based on this definition. We have 2 formulas that we're going to use. And these guys are on your formula card. That laminated one, I gave it to you at the very beginning of the year, probably on day 1 of school, like your first day in class. It's laminated and it's got these guys on there, all right? So what you're going to do is when you read a problem, you have to decide, am I picking one thing? Okay, so the big deal is this is select one. Select one card, select one person, select one item, select one animal, select one. If you're picking one thing, and it's 2 events, right? The probability of it A happening or B happening, all right? So with this, if you look at it, if they're mutually exclusive, that means they cannot occur at the same time, which means they don't overlap. If they don't overlap, you can just take the 2 probabilities and add them together. Whereas if they do overlap because they're not mutually exclusive, then what you need to do is it starts out the same. Probability of A or B is equal to probability of A plus probability of B. But if there's an overlap, you need to subtract the probability of the overlap. Sometimes you'll see me write probability of both. Probability of it being both categories at the same time. So the key is that the word problems aren't going to tell you which formula to use. They don't say, like, these are mutually exclusive events. When you read the problem, you have to say exactly what we did up here. Which of these categories is it? And then once you know that, then you know which formula to use as you go. So a Dracula has a bag of chips with pictures on them. There are 9, or like poker chips you could visualize, okay? Or tokens. There are 9 tokens or chips with teeth, 4 chips with bats on them, and 7 chips with spiders on them. If he chooses only one, right, select one from back up here. He chooses one chip while blindfolded. What's the probability he chooses a chip with a tooth or a bat? So the first question is there overlap or not? There's no overlap. It can't be both. It can't be a tooth and a bat. It's one or the other. So that means that with that, if there's no overlap, you're going to go here. You can just add them together. Now, I'm going to write it in notation because, again, like I said last lesson, it's really important that you get in the practice of writing the notation because we're going to build and build and build with lots of different symbols. Probability of picking a tooth or a bat is probability of tooth plus probability of bat. Tooth is 9 out of the grand total is 20. Bats, there are 4 out of 20. So our answer is 13 out of 20. Again, you can divide this down. You would get 0.65. That's fine as well. It doesn't matter either way. Okay? There we go. So, next problem. The probability that a randomly selected student is a senior is 0.25. The probability that a randomly selected student is female is 0.52. If there's an 18% chance that a randomly selected student is female and a senior, find the probability that the randomly selected student is either a senior or a female. This one has a whole lot going on. Oh, sorry, I was off the screen. This one has a whole lot going on. So, you've got a senior. If I were you, when you've got a lot, I would jot it down off to the side. Probability of senior, 0.25. Probability of female is 0.52. Probability female and senior is 0.18. Find the probability that a randomly selected student is either a senior or a female. So we want senior or female. And that's what I want. So I'm going to put a question mark or an X. Well, now you have to ask yourself, is there overlap? Yes, absolutely, right? There's lots of you in our class that are females and seniors. So with this, that's when you set it up where you subtract the overlap. We're going to be using this formula here. Okay. So it's going to go probability of senior or female is probability of senior plus probability of female minus probability of senior and female at the same time, okay? Or minus the probability of both, if you want to look at it that way. Probability of senior is 0.52. Probability, 0.25. Probability of female is 0.52. Minus probability of both is 0.18. And this is what we want. This is what we're looking for. So 0.25 plus 0.52 minus 0.18 is equal to 0.59. And that's your answer. Okay? So if you want, you could pause and like try these next couple ahead of me, or if you want to watch as I go through them, you can. Example 4, city has 9 coffee shops, 3 Starbucks, 2 Caribou Coffees, and 4 Dunkin' Donuts. Actually, I should probably just call it Dunkin' now, right? If a person selects one shop at random to buy a cup of coffee, find the probability that it's either a Starbucks or a Dunkin' Donuts. So, is there overlap? No, there's no overlap because a coffee shop can't be both of these at the same time. So, we want probably of Starbucks or Dunkin' Donuts. It's just Starbucks plus Dunkin' Donuts. There's a total of, 9. So we have 3 out of 9 plus 4 out of 9 will give us 7 out of 9. Done. All right. Example 5. Patrick draws a single card from a deck. So he picks one card. Find the probability that it is a king or it's a club. First question, is there overlap? Are there cards that are counted in kings and clubs that can be counted in both? Yes, the king of clubs. So there is overlap this time. So that's where I'm going to say probability of king plus probability of club. That's the one that looks like a clover leaf, right? Minus the probability it's a king and a club at the same time. Kings, there are 4 of them. Clubs, there are 13 of them. Minus a king and a club at the same time, there's 1 card. It's the king of clubs. So there's 1 card out of 52. So 4 plus 13 is 17. 17 minus 1 brings us to 16 over 52. And when you simplify that, you get 4 out of 13. If you don't really know your playing facts, in Google Classroom, I posted in classwork under the chapter 4 topic a picture of, it's like an image of playing cards, and it's in color. So if you want to print that, you could, or just save it on your computer, you could, just so you could kind of look at the deck. It's like a picture of all 52 cards in the deck. It's helpful for those of you who don't know your cards very well. Here we go. Example 6. Abby draws a single card from a deck. Find the probability of pulling a jack or a black card. So, is there overlap? Yes, there's overlap because you can have black jacks, jacks that are black. So we're going to have probability of a jack plus probability of a black card minus probability that the card is jack and black at the same time. So jacks, there are 4 of them. Black cards, there are 26 of them, half of the deck. The spades and the clubs are all black. Minus, there are how many jacks that are black? 2. There's the jack of spades and the jack of clubs. So 4 plus 26 is 30. 30 minus 2 is 28 out of 52, which leaves us with 7 out of 13. Again, it's fine if you make these decimals. Just carry them a couple decimal places. All right, number 7. On New Year's Eve, and this is a fictitious problem, the probability of a person driving while intoxicated is 0.32. The probability of a person having an accident is 0.09, and the probability of a person having a driving accident while intoxicated is 0.06. So that means probability they're intoxicated and they had an accident. This is both, right? Is 0.06. What's the probability of a person driving while intoxicated or having a driving accident? So probability of intoxicated or accident is equal to the probability they're intoxicated plus the probability they have an accident minus the probability it's intoxicated and accident, or both. Intoxicated, 0.32. Accident, 0.09. Intoxicated and accident, 0.06. All right. Should equal 0.35 when you plug all that in your calculator. And that's our answer. Okay, this would copy down. So now, I really want you to try this one on your own. All right, and I know it's easy to just, she'll never know. I'll just let the video play and, just keep going. No, really, you got to try probability independently and on your own. Like, you have to practice on your own. So pause it, try this, and then unpause it and come back. We have probability of soccer is 0.3. Probability of basketball is 0.22. Probability of soccer or basketball is 0.44. And this problem is saying find the probability of them playing both, which is the same as me saying probability of soccer and basketball. Right? These are asking for the same thing. So, if you have probability of soccer or basketball is equal to the probability of soccer plus probability of basketball minus probability of both soccer and basketball. The or 0.44 goes here. Soccer is here. Basketball is here. This is what we don't know, so I'm going to write minus x. Hopefully you got it set up like this, right? You might have been like, wait a minute, what am I supposed to do? But it's okay. The two that I showed you before, this is what was missing. But in this particular problem, we have this probability. We don't have the overlap, the and. So now I'm going to have 0.44 equals 0.52 minus x. I'm going to subtract 0.52 from each side. I'm going to get negative 0.08 equals negative x, which means x equals 0.08. Which means your probability of both soccer and basketball is 0.08. Excuse me. So now let's look at number 9. Okay. If you have a two-way table, this way you can read it two ways. The first thing you want to do is total it, right? Total each column, total each row like I've done. Figure out your grand total. 60 plus 56 is 116. Check to make sure that it isn't already totaled for you. Sometimes they're already totaled for you, which makes stuff so lovely, all right? And this is saying at a large company, employees were surveyed and classified according to their highest level of education and whether they attended a sporting event at least once a month. The data are shown in this table below. So the first thing we want to do, question A, if an employee, so this is pick one, right? Because later we do more than one. So right now we're picking one employee. Find the probability that the employee is a high school graduate. So high school graduate means we can ignore these two. We want just this column. There are 28 high school grads out of the 116 that we have. All right, and this is where once your fractions start getting bigger, I love to just convert them over decimals. This doesn't really make sense as a number, right? Like we know that it's a fraction and you could simplify the fraction, but if you divide it down, this makes sense, right? This is 24.14%. That's a logical answer. Okay, it's something you can visualize. Part B, what's the probability that they attend sporting events once a month? So attend sporting events once a month means we just want this column, this row, okay? We just want this 60 out of 116. I'm going to divide it down, and I get 0.5172. All right. Now, C, what's the probability they have a four-year degree or they attend sporting events once a month? So now I'm saying four-year degree or they attend sporting events. Do you see how four-year degree and attend double counts this cell? Okay, that's the overlap that we've been talking about. You could do probably a four-year degree or attend is the probability of four-year degree plus probably they attend minus probably they have both, four-year and they attend. Four-year degree is here, 49 out of 116. Probability they attend is 60 out of 116. But the 60 and the 49 counted the 24. So we counted the 24 twice. So we have to subtract a 24 so it's not double counted in both categories. This becomes 85 out of 116 or 0.7328. Now, if it's a two-way table, I'm okay with you guys just adding the cells, right? Add here, 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 here. And just make sure you don't double count the 24. That's totally fine. Just be careful as you work on it. That only works in a two-way table, not a word problem like this basketball problem. But it will work here. Okay, just like does not have a four-year degree, you have a couple ways you can do this, right? Does not have a four-year degree means these two. So one method would be to do probably of high school plus probably of two-year degree. All right, high school is 28 out of 116, two-year degree is 39 out of 116, and we're going to get 67 out of 116, which divides down to 0.5776, okay? Or the other way you could have solved this problem is you could have said probably of not four-year is equal to 1 minus the probability that it is a four-year degree. All right. Well, four-year degree is 49 out of 116. So 1 minus 49 out of 116 leaves us with 67 out of 116, which is the same answer. It doesn't matter which way your brain sees it. It's just whatever makes sense to you. Okay, so on the next page, there is this big problem. Here are the totals. Okay, I want you to do these 4 down here. They're uglier fractions, but they're important. So do those 4. And then here are my answers. And please let me know the next time we have class what questions you have. Okay, read through them. Like, hopefully you tried them on your own. Okay, and then we're going to talk about them. Good job today.